This is the second part of the lecture on composite figures estimating area and area and perimeter in the coordinate plane. On this problem, I'm giving you coordinates, and it says find the area of the polygon with these vertices. Well, when you end up plotting these coordinates out, you get this figure, this quadrilateral looking thing, and you'll notice that you don't have any horizontal or vertical lines. Well, don't panic. Just follow along, do this problem with me, and you'll see where it's not as bad as a problem as it looks. What we're going to do is use a process called subtraction. And what I need to first do is make a box, a rectangle, around the entire figure, like this. So what I'm doing is I'm making a box that includes all the kind of the corners, so to speak. And the reason that's so effective is, well, what I've just ended up doing is, hey, how easy is it to figure out the area of a rectangle? Well, that's no problem at all. How easy is it to figure out the area of 4 triangles? No problem at all. Well, if I subtract the area of these 4 triangles from the area of the rectangle, I'll actually end up with the area of this red quadrilateral. And so that's what I'm going to do. So to the board, I'm going to say, hey, the area of this red quadrilateral looking thing, right, is equal to the area of the big rectangle minus the sum, and I'm going to use math language here, this means to sum the area of the 4 triangles. Okay, I can handle that. All right, so wait a minute. This triangle here, and let's use yellow again. I think you guys really like yellow here. This total length is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is an 8 by 12 box. So on my 8 by 12 rectangle, so the area of the big rectangle is 8 by 12. 12 times 8 is 96. Okay, now what I need to do is find the area of the 4 triangles. Well, wait a minute, this isn't so bad. Let me change colors once again. Let me go to a green here. Now, this triangle here has a height, so I've got a triangle here, has a height of 2, and 2 by 10. All right, so this triangle, 2 by 10, 1/2, 2 times 10 is just 10. So I know the first one. Let me just do it this way so you know what I'm talking about. So the first one's 10. Plus the next one up here. Well, if this is 2, this has got to be 6. All right, so that's 6. And then I'm going over 1, 2, 3, 4. 6 by 4. 1/2. 6 by 4 is 12. The next one, if this is 4, that means this has got to be 8. And if I go down 1, 2, 3, 4, 5, 6. 6 is right there. All right. 1/2, 6 times 8. Again, that's 24. And you can see that this isn't a difficult process. It might be a little tedious, but it's sure a lot easier than figuring out the length of each one of those diagonals. And oh my gosh, holy cow. All right, and then of course the last one here, this is a mere 2 by 2. And that's just 2. So now I add all 4 of these triangles together, and I get 10 plus 12 plus 24 plus 2, and I do 96 minus second answer. It's 48. So the area of this red polygon in the middle is, so the area of that polygon thing is just 48. That is called the subtraction method to figure something out. Now the last two things we need to talk about are really just way cool, and it has to do with estimating the area. Now when you estimate area, estimate doesn't mean it's an exact solution, it means it's a pretty close solution, and some estimates are better than others. The first method of estimation is with composite figures. So take a look at this little lake, and each side, let me write this down, each side equals one, we'll make it a mile, 1 mile, right? So this is a mile, 1 mile by 1 mile, right? 1 square mile, great. So when we use composite shapes to estimate the area, what we want to do is break this down into figures that are really easy to work with, like triangles, rectangles, trapezoids, and whatnot. So the way I look at this is, okay, wait a minute. I've got 3 figures here. I have a triangle. I have a trapezoid. Yeah, I'm just going to go like this. That looks more like that. That's a trapezoid. And then I have another triangle there. Okay, so again, what I have to do is just add the area of, find the area of each of these 3 shapes, and then add the areas together. Okay, well this triangle is 1/2. The height is 2, from here to here is 2, and the base is 1, 2, 3, 4. So this area here is 4. Now this one here, I'm assuming this is it's 1 here and 1, 2, 3, 4 down here, and 3 up here. I'm writing it sideways, I know it looks a little confusing. So this one, area of a trapezoid equals 1/2 base 1 plus base 2, and then times the height. So I've got 7 divided by 2 times 1, and that's just 3.5. The last figure here is a triangle. It's 1/2. The base is 2. The height is 1. So that's just 1. So when I add the 3 figures together, I get the area of the polygon, the whole thing, is equal to 4 plus 3.5 plus 1, and that's equal to 8.5 units squared. Now, what's important here is to go back and say, wait a minute, how big is each unit? Well, each square is 1 mile by 1 mile, or 1 square mile, which means this is really 8.5 square miles. The next method for estimating area has to do with full and partial boxes. And so this is actually a really cool technique. We're going to do the exact same problem, and we're going to estimate the area. And in this method, the box is either completely full, or any bit full we're going to count as partial, and I'll show you how we do this. So I've made a little note here. Partial boxes equal 1/2 a full box. Now, even if it's just a little bit marked, what happens is, on average, it works out. So we're going to say this is a 1/2. This, or I should say 1/2. It's a partial. Partial, partial, partial. I'm going to go over here. Partial, full. Right? We're going to call this partial. Full, partial, partial, full, full. I'm not going to count that in. That looks like it's actually falling right along this line. Partial, partial. Okay, now let's just count this up. The number of full boxes, I've got 4. The number of partial boxes, 1, 2, 3, 4, 5, 6, 7, 8. Divided by 2 is 4. Now, the next thing it says, the area of each square, well, on the previous problem I said it's a 1 square mile. So the area of each square is 1 mile by 1 1 mile. So that would be 1 square mile. Now, the sum of the full and partial boxes, okay, the number of full boxes here is 4. Number of partial boxes divided by 2 is 4. So I end up with 8. And multiplied by the area of each square, we're estimating it at 8 miles squared. Now, you can see that in this full and partial box method, I figured it was 8 square miles. If I use composite figure, I got 8.5 square miles. You know, maybe I should have, you know what, maybe I should have counted that because it goes out just a little bit. But that's kind of the devil in the details sort of thing. I think you get the idea. So let's do one more problem, and we'll use the great state of Texas. Now, in this problem, each side, each little square, the side length of each square is 96 miles. So right off the bat, let's just say, hey, what is the area? Let me get my picture out of the way. I can't get it out of the way that much. Well, I'll move it out of the way later. 96 miles, so 96 squared, right? Because each one of these boxes is 96 by 96. So 9,096 squared, and that's 9,216 square miles, right? Because again, 96, 96, all these squares. Okay, so let's do the same method. Let's count the number of full boxes and partial boxes. Well, first thing we need to do is mark them. All right. I'm going to go back. All right. It looks like it's cut off. There's a bay there. This is a little bay. It might not show up that well, but there's a little bay cut out. That's the Rio Grande. It's not a bay. That one's got a little bit taken out. That's taken out. There's a little bit there. And you can see how this little bit here and this little bit, you can't see what I'm pointing at. There's a little bit there. Okay, now, what I was trying to say before is, you can see like there's a little piece missing right here. Well, I can also factor in that there's like a little itty bitty piece of land right there, and together those make a full box. All right, that's my bell, but I'm not going to worry. I'm just going to keep going and do my problem. All right, so quickly, let's count the number of full boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Number of partial boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 27 divided by 2 is 13.5. So now I add my full and partial together, so I've got 18 plus 13.5, and I get 0.5, 3, 1, add another 1, 31 and a half. Now I multiply 31.5 times 9,216 miles square, and I get, if you're ready for this crazy number, here it comes, 31.5 times 9,216. Holy moly. Each one, did I do my math right? Yeah, that looks right. 290,304. So I've just estimated the size of the state of Texas to be 290,304 square miles. So I hope this helps. Again, multiple ways to estimate area, how to do more complicated problems in the coordinate plane. Now go ahead and try the two sets of problems from 10.3 and 10.4.